Okay, so we've been working with oblique triangles. Remember, oblique triangles are just triangles that do not have a right angle in them. So we might have a triangle that looks something like this. And let's say that we are told that this angle here is 41 degrees, that A is 18 inches, and C is 23 inches. And I ask you to find the other pieces. When we're dealing with an oblique triangle, the first thing we should always look for was, first of all, identify what we know. We know two sides and one angle, which is kind of a dangerous situation. If we have two angles on one side, it's fairly easy, straightforward. But if it's two sides and one angle, we have all sorts of bad things that can happen. It could be two different triangles, all sorts of things. But anyway, once we've identified what we know, the next thing we look for is always, do we have an angle on its opposite side, or a side in its opposite angle, however you want to look at it. In this case, do we have a side in its opposite angle? No, we do not, which means we cannot use the law of sines. We have to start out with law of cosines. So now, the side that we're going to be looking for is the side that is opposite the angle that we have. So the side we're going to be finding is side B. Now, often what I would do is I would relabel it so that this is angle C here. Does that make sense? Because angle C is the one we're used to looking for. So I would just switch B and C so it's like that, because that's what fits our formula. So anyway, C squared, or C is going to equal the square root of, instead of doing C squared, I'll just put C equals the square root of A squared, so 18 squared, plus B squared, so 23 squared, minus 2 times 18 times 23 times the cosine of 41 degrees. That formula look familiar? Everybody confident they can put the numbers in that formula? Good deal. So now, 18 squared plus 23 squared minus 2 times 18 times 23 times cosine of 41 degrees. 15.10. So C over here is 15.10 inches. So now we have all three sides and an angle. Once we have all three sides, of course, now we have an opposite side or an angle on its opposite side. So now we can go back to doing law of sines. So we're going to use that measurement we just got, the 15.10, over the sine of what angle? 41. Equals, which one do we want to use first, the 18 or the 23? The 18. We always want to use the smaller one first, just in case the largest angle might be obtuse. There's a chance that angle C could be obtuse because it's across from the longest side. So we want to do the smaller one first. So 18 over the sine of angle A. So 18 times sine of 41 divided by 1510. Point 7821. So we do an inverse sine. 51.45 degrees. So this is 51.45 degrees. Now to find angle C, what do? We add these together and we subtract from 180, which is going to give us 87.55 degrees. Had we tried to find angle C here first instead of before angle A, we would get that 87.55, and it would be pretty much impossible for us to know, is that really 87.55 or is it 92.45? Because remember, when you do an inverse sine, it can either be that angle or its supplement. And only the biggest angle can be obtuse, of course, because you can only have one obtuse angle in a triangle. But that's why we always go for the smaller side, is so we know for sure. Because we subtracted from 180 to get this angle, we know it's 87.55. It cannot be 92.45. It cannot be the supplement. So there, we did the law of cosines to find the first side. And then after that, we used the law of sines to find the other parts. If we had started out with a side and its opposite angle, we could have just done law of sines right from the beginning. Like in a triangle like this. If I call that 68 degrees, this one's 64 degrees, and this side down here, 12 inches, and I can label this whatever I really want to. How would I go about solving this one? Well, this one's our simplest case. I've been given two angles and a side, which means I can always find rather quickly the last angle. How do I do that? 64 plus 68, and then subtract that from 180 gives me, what, 48? 48 degrees. Now I can use my law of sines. I've got the 12 over the sine of 48 degrees equals, now it doesn't matter which one I use because I have the angles. It's when I'm looking for the angles that I got to worry about whether it's acute or obtuse. So I'm going to put A over the sine of 64, and we will cross multiply and divide. So 12 times sine 64 divided by sine of 48. 14.51. So A is 14.51, and that is in inches. Then we do the same for B. It's still 12 over the sine of 48 degrees equals B over the sine of 68 degrees. So now B better be our largest side because it's opposite the largest angle. So cross multiply and divide. 12 times sine of 68 divided by sine of 48. 14.97. And yes, that makes sense. Our largest side is opposite the largest angle. Smallest side's opposite the smallest angle. Something we should always double check on these to make sure that comes out. Now our third option is if we're given a triangle like this, and I'm told that I have all the sides, and I'm asked to find the angles. So I pick an angle to find first. I'm going to pick angle C because that's what the formula works out for. So I know that C squared equals A squared plus B squared minus 2AB cosine of angle C. So So I'm going to plug in c squared is going to be 16 squared equals a squared will be 19 squared plus b squared will be 18 squared minus 2 times 19 times 18 times the cosine of c. Now remember we mentioned this. You can think of this, the cosine of c, as being your variable, as being x. And we're solving for it. But the first thing we have to do is calculate what we can. 16 squared, of course, is 256. 19 squared is 381. 18 squared is 324. 2 times 19 times 18 is, what, 684, I believe. Yeah. Then times the cosine of c. There's nothing we can simplify there. So now before I do anything else here, I can combine these two. 381 plus 324 is 705. Why can't I subtract the 684? Yeah, it's multiplying the cosine. I have to it has to multiply before it can be subtracted. So once I've got to this point here in the purple, that's as far as I can go simplifying that. Now I just have to start solving the equation. Well, I'm going to subtract the 705. So 256 minus 705 is 449, I believe. Negative 449, is that correct? That equals negative 684 times the cosine of c. And now I'm going to divide by the negative 684. You'll notice I didn't bother putting in the negatives because the negative divided by negative is going to be positive. 0.6564. And I do my inverse cosine to get that c is, so second cosine, second answer. C is 48.97 degrees. Now, of course, I can find my other sides, or other angles, I should say. I have 16 over the sine of 48.97 degrees equals, I'll use the 18 over the sine of, what's its opposite angle? B, very good. So we'll cross multiply and divide to find the sine of B. Times 18 divided by 16. It's 0.8487. And then we'll do the inverse sine. See that B is 58.07 degrees. Now again, you'll notice I did the smaller angles first, just to avoid this possibility. So now I'm going to just add up and subtract from 180 to find angle A here. And what's that add up to? 107.04. So this is going to be 72.96 degrees. What do you think? Good stuff? So when you finish the quiz, you'll be done for the day. But you can pick away in your packet on page 385. There's an achievement review. Applications of trig. What's that?
Did you guys go over the 10 through 17? The word problems?
Yeah, we kind of did. We didn't necessarily do those exact problems, but tell you what, tomorrow we can go through them. Tomorrow's going to be a review day
Okay.
because we're done with Unit 3, which means Thursday will be Unit 3 tests. Yeah.
I wrote